And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today we're carrying on with our Quad 34 preamp, which we thought we'd sort of fixed last week, but turns out it was down in one channel. Let's get on with it. Right, before I get on with the main event, I'm just going to show you this little thing that I have built, which is going to aid our fault finding. The usual sort of pure radio thing that you see sitting at the back of the bench, it's only mono. And I think that's why we sort of failed to spot the fault earlier on. And I used to have that little SMSL amplifier that I used to use on the bench from time to time when sort of diagnosing stereo faults. Unfortunately, that's been pressed into service elsewhere. So what was needed was a new little amplifier to just leave on the bench. And so I thought, well, what have I got kicking around? And I've made this little 3D printed enclosure. All it is, we've got 4 terminals on the back there with the speakers. Let's have a little zoom in on the top camera so you can see what's going on. There you go. So yeah, we got 4 speaker terminals on the back. We've got a set of phono plugs in here, an LED to show what it's on, and one of these little amplifier boards. You can buy these really cheap from the usual eBay suppliers and others. And it's equipped with a PAM 8403 amplifier IC. It's a little Class D thing, runs off 5 volts and gives you 3 watts per channel at an atrocious 10% distortion. However, I'm not looking for trouser flapping amounts of volume in here. 3 watts is more than enough, and I don't really care about the distortion because I wouldn't be measuring that with it. So yeah, let's plug it into Old Faithful and just give it the beans. It's a little bit hummy, I have to say. We're not using a screened enclosure. I paid almost zero attention to layout, etc. But yeah, it's okay. So let's bring up the old. So there we go. We've got a small stereo amplifier, which is just perfect for testing out this kind of thing. So it's not going to come out on the microphone because my lav mic is only mono, but yeah, take my word for it, that's in stereo. So there you go, we're going to be using that to diagnose our quad. Let's get onto it properly. Okay, so I've got the amplifier set up again. I've got it wired on its outputs into our new little workshop power amp there. You'll notice I stuck a bit of heat shrink over the speaker terminals there because I wasn't happy with them just wandering about on the bench. But there we are. Right, this is where we're at. I've got a signal coming in here into our disc input, which is set for CD levels on this particular unit. Outputs feeding the power amp. This is where we are. We're set to disc, and yeah, that is only coming out of the left-hand channel. Again, bit difficult to hear when you're listening in mono like you lot are. If I turn the balance control to the right, there is nothing on the right-hand side of the balance control. Now, the balance control works as 2 pots in this unit. So what happens is, as you turn it towards the left, the right-hand channel gets turned down and the left-hand channel gets turned up, if you like, and vice versa. So either the balance control could be faulty or there's nothing going into it. If I push the mono button, the unit is monoed right at the output stage, just before those transistors that were muting the circuit last time. Just before there's an analog switch that just puts the left and the right channels together. And trust me, that is left and right together. I now have something coming out of the right, but clearly none of the right-hand information. So let's just have a quick look at the schematic and show what I'm going to do. Okay, so this is the output. There are 2 op amps here. Not quite sure what that analog switch is doing, but here's our mono switch here. So we know that part's working, so everything to the right of there is absolutely bob on. We have got some stereo switching. IC18, that's just switching some filtration in, as is that. Ah yes, filter 1 and filter 2, look, and not filter to. This is the bit I'm interested in. Here's the balance pot, and here's the other channel's balance pot. And as you can see, one turns one down and one turns one up. They'll be effectively wired back to front for each channel, so the control moves in the same direction. So I think what we need to do is see whether there's any audio getting into our ambler tone control section here. And that's quite convenient because we've got a coupling capacitor here at C36 and C37. So if we've got audio on both of those, then the problem is in here. If we haven't got audio on there, it's to the left again. So, you know, there's a couple of hundred mics here. That could be problematic. A couple of op amps and our active volume controls here and here. So, right, let's take a step back through here. So C36, C37, and just see what's on there. Okay, I have located IC9, which C36 is there, C37 is there. Let me just switch sources. So C36, you can see on the scope there, there's our 1 kilohertz square wave test tone. And on C37, I got nothing. Excellent news. Back to the schematic. Right, we've got audio here. We haven't got audio here, which means everything to the right of here should be okay. So we are looking back along here slightly. So I think the next step is to have a look at C30, C31. Well, we know we're going to have audio at C30, but see if we've got audio at C31, and then if not, we're into this mess over here with these analog switches. But let's go for the first bit first. Or we can have a look on pin 3 of IC6, and that'll see if IC6 has failed there, and yeah, taken out our audio there. So C31 first, and then maybe pin 3 of IC6. Right, back in business. So C30, we'll just have a look on the scope. This is a signal we should be expecting. And yep, we got lots of square waves there. It's a little bit quieter than before. I've had to adjust the volts per division. And on C31, almost nothing. From the other side of C31, again, almost nothing. So now we just need to locate IC6. Have a look at one of the pins of that. Let us see if we can't locate IC6. 26 is over here. 23 is in the power supply. IC9, IC12. Let me zoom out of it so you can see what's going on. That's the wrong way. I'll get the hang of that one day. Where's IC6? Shout if you see it before me. Okay, well, let's follow the capacitor back, shall we? It goes straight into pin 6. Alrighty. So that end goes to pin 6 somewhere. Must be on the other side of the print, which isn't going to make it very easy to follow, especially as there's a silk screen over the other side. So back to the other method. Where are you? IC6. I'm just going to turn this off for a second, take my scope probe off, have a look on the other side and see what we've got. Right, we've got 4 chips here. 10, 13, 12, 9. Okay, it's neither of them. We've got one over by here, which is our IC20. It is definitely IC6. That one there, IC19. These two, 24, 27. These two, 8 and 7. Where is IC6? Over there, IC25. Maybe we don't have the right schematic. Hang on just one moment. We've got IC7 and IC8, you'd think, wouldn't you? Right, well, after a lot of messing around with trying to find the right schematic, it turns out IC6 isn't fitted in this unit. It is in fact IC27. So the output, can you see that? You can. The output from IC27, as you can see, is nothing. And on the other channel, there's our waveform. So if we look at the input to our DUF channel on IC27, we can see it's nothing. And if we follow that back, it goes to IC1 there, on which there is nothing. But on its input, if I can find it, there it is. So IC1 is another analog switch. It's not a 4066 in this instance, it's a 4016. So knowing how fragile a analog switch IC is, I'm going to take a punt that that's our problem. Now, let me go and see if I've got one in stock. Alrighty. The gods of new old stock have smiled upon me, and I have a 4016. So that's good news. So, yeah, it's time to evict our old IC1. So first things first, let's give it a dose of fresh solder. I believe we should be free. I see one is here. I'm not going to get my chip puller in there, am I? I'm going to have to abuse it with a screwdriver. And here's our new one. Thoughtfully, they haven't marked the direction of the chip on the board. Thankfully. One, I've got a lot of footage if I did have to refer back to it, but also I know which way it came out. Right, where's my leg manipulating tool? A little squish there, there we go. Slide it into the hole. There we are. 4016, 4016. And just solder the new one in. That's it, we can clean the flux up if that has affected a repair. Right. I don't really want it up that way, do I? Want it up this way again, or rather still. IEC mains lead in. We are off. So, mains going on. It's still the same. Oh. Well, do you know, I'm not sure one of those pins is soldered up. You see, this is why you should test, test and test again before condemning a part. I've taken a punt and I'm wrong. I think that pin's okay. Let's try again. No, still exactly the same. Right, back to the schematic. Let's see where this signal comes from and goes to. It is part of the tape loop select. So let's get into that. Right, well, I've had a merry skate round. Now I've got the correct schematic. And it turns out I found the tiniest wisp of solder, which was shorting out IC25's right-hand output. And I thought, hallelujah, this will be it. No, it's still the same. I have, however, now got signal all the way up here. So these original capacitors I was checking, there's your left-hand one there, look. And there's the right-hand one. So I've now got two lots of input. So you follow that round to the balance control, and there's the balance control for the right hand channel, and that I believe is the output there. So if I turn the control, there you go, you can see that going up and down. So here's the interesting thing. There's the input to the left hand side of the balance control, and there's the output. Absolutely nothing. So we've come back round to what I said right at the start of the video when I said, I bet it's the balance control. Did I? I'm sure I did. I thought it anyway. So, power off. And let's see what's going on with this balance control. Don't even know how it works. There it is. Well, it's just... I'm going to have to zoom in a little bit. See if we can't make this a decent shot. There, you can see this is the volume control here, and that's just working a stepped attenuator type pot thing. But there's the balance pot, look. And it's on a slider, which is on the bottom. And it's open circuit. So, yeah, that is now our problem, or at least one of them. Maybe there are more. This thing has thrown me so many curved balls, I don't know what to expect anymore. So, let's give it a bit of a birthday and see if that does... Oh, if I'd have spotted that the balance control was a slider at the start, I would have given it a birthday to start with. I have to say, it's all moving about quite nicely in there. Right, what do we reckon? I've still got no faith in this thing whatsoever. Right, switching on. Nope. So, this is going to be a right set of fun and games to try and obtain either a replacement pot. See if we can't get that one out and find out what's wrong with it. Just one quick sanity check. What does it feed after it leaves the pot? Filter switch. Unless somehow the output of the pot has gone to ground. I mean, that's possible, isn't it? Let's zoom back out. There you go. Right, we are on ohms. So one side of this lot is going to be ground, which is that there. That's millions of ohms. And that's kiloohms. It's gone open. We've got no right hand channel. That's... Oh, it's gone down 2k to ground. Trying to see which way it's wired. It's not quite straightforward because obviously the pots have to cross over. So as you move it one way, one side is going low resistance to high resistance, vice versa on the other side. So let's set it about amidships and see what we get. Yeah, it'd sort of be on a ground really. 2k there. This is the good side, the left hand channel. About 2k there. And on the bad channel, millions of ohms there. And about 2k there. Yeah. What's my chances of getting another one of those? Let's work it backwards and forwards a few times. You never know, the deoxit might be doing its shizzle. Still millions of ohms. About 2k. About 2k. About 2k. Ah. Right. There's only one thing for it. The front panel is going to have to come apart. Something I was hoping I wouldn't have to do. So I got a sneaking suspicion this is going to be a swine job. But still, it's no good like it is it? Well, it turned out one of my camera's memory cards filled up, so I had to stop there. I've got all the knobs and switches off the front now. I'm not going to remove this balance one. I'm hoping that'll come out with the front panel. But the next thing to do is to remove the front panel itself, which doesn't look to be perhaps the easiest thing in the world. There's a lot of screws and it looks to be a bit of a fiddle. But hey, let's see what comes of it. So there's one screw on this sort of support bracket here that supports the controls. Two on the side there. Two on the other side over here. Yep, and is it just the one underneath? Yeah, I think I can unhook the linkage to the balance pot on my way out. I'm hoping. Oh, maybe not. Ah! I think I am going to need to remove those two screws to support the balance pot there. Yeah. Okay. Right, I've now gained access to the balance pot itself. You can see the mechanism in. Quite clever. Why didn't they just use an ordinary pot? Anyway, let's get that unhooked. Oh, okay. Can I just take that off? Or am I going to break something? I was hoping I could just jiggle that out, but I don't think I can. See if I can't remove this press washer here. And just disconnect the linkage that way. I hate these press fit washers. It's like a washer with some splines and you push it on and the splines go the one way and it won't allow it back off again. Horrible things. Not from an ease of manufacture point though, they're quite handy, aren't they? There we go. Managed to wiggle it off. One linkage removed. Now I suppose we need to desolder the pot and see if we can't somehow effect a repair. Right. I'm hoping if it's an Alps pot, it might still be available. Oh, there it is. It's a bit oily because we've had some deoxit in there. Doesn't look very robust, does it? It is an Alps pot. 2K as we knew. Right, let's see if we can't figure out why it's open circuit. It is possible we could just uncrimp it and take the bottom off and see what's going on in there. Don't want to do that unless I have to, but I'm quite willing to take the risk because it's no good like it is. Right, multimeter 2 ohms, you can see that. So yeah, we just got to work out what's what here. Presumably these are the tracks. 2K. So both tracks are okay. So presumably that's the bottom one. 1.5K. And this one over here is the top one. Yeah, it's the one that's open, isn't it? Totally open circuit to the wiper. What's the worst that can happen? Let's just take it apart. Gently fold these taps back. I'm using a pair of cutters here, just so I can get under them, just to fold them back neatly, rather than sort of bumbling about with a pair of pliers. Oh, there's the problem. We are totally missing a set of fingers on the pot there. It's supposed to be a stereo pot, so we should have 2 sets in there. And we're missing a set. And they're not inside. Oh dear. We are in trouble. Wish I'd spotted this sooner, I really do. Spent a lot of time on this now. Let's see if we can get a new one, shall we?
4 to 6 weeks later.
Right, well, it's actually been a month since I've had a chance to get into the workshop. Pressures of other things going on. I did manage to find this slider in my box of bits. Don't know what that came out of. It is an Alps. I did pop the back off it, and the slider in there is colossal. The little fingers that we need to repair this one, it was just colossal, so not a lot of use. So I did get on eBay and I've received this little package from Nemo Clock. I did try looking for the original pot and it's totally unobtainium. Gift, wishing you all the best with your project. What have we got there? Bag of capacitors, always welcome. What are they? 4.7 mic at 16 volts. Thanks for that. They'll come in handy for something, won't they? Anyway, I've bought this, so let's just find some form of opening tool to get this apart. Let's have a go with a spudger, shall we? It's very good. I believe this seller is in the Balkans somewhere. I think Bulgaria, maybe? Is that in the Balkans? My geography is terrible. It arrived reasonably fast, and it did look about the right size. It is, however, only a monopod, but it was the size that was giving me the problem more than anything else. So there we go. This is 5K, which is sort of the wrong thing, but yeah, it's sort of got the similar kind of pins on it. So I'm just going to tweak that apart and see if it's got a similar kind of wiper in there. Let me have a little zoom in. There you go. Right. Gently bend these tangs over. It's better. Is it going to be good enough? It's very similar sort of construction to the Alps pot, but I'm just not sure that's going to be able to fit. It looks a bit wide, doesn't it? Do I risk pulling it apart and wrecking it? What other options have I got at the moment other than bodging another pot in? No, it's just going to be too wide. Oh, that's a shame. Right, this calls for a Sports Direct levels of T, a little bit of a think, and I've got another couple of plans. There's a plan B and there's a plan C. Right, I've carefully considered my options, and yeah, we've got A, B and C. So the first and most bodgy fix I sort of thought of is to just put some resistors in there where the balance control initially lived and just fudge it so it doesn't work. Plan B involves a pot similar but not the same as this. And what I thought was I could drill a hole in this bracket here, mount the pot in there, 3D print a little shaft on the pot, and then when this lever moves back and forward, it can then, you know, move the pot at least partially left and right. So, alright, you probably won't get all of the way across, all of the, but when do you ever need that? And at least we've got some functionality and the appearance remains the same. Plan C is to get a pot drill hole in the back panel and wire it up that way. I think option A with the bodges and resistors and just eliminate the control is probably better than that. At least the cosmetics, I mean, it's not in great nick as it is, but at least it does sort of maintain it a bit. So I need a 2K linear stereo pot, which I have just ordered and hopefully will be here in a few days.
4 to 6 weeks later.
Right, it's been a little while since I've worked on this quad because other things got in the way, but there we are. I have got a 2K linear dual gang pot. Quite a small one, and there's method in my madness, I hope. It is of course a rotary and not a slider, because I cannot find any kind of slider that's going to fit in there, or even rob bits out of another one to make it all work. So here's my plan. I've got two plans really. One is the horrible bodge when everything goes wrong, and that is to take my balance pot, drill a hole in the rear of the case and make a rear mounted balance control. And whilst that will work, it's pretty horrible as a solution. I don't like it. Plan A is to drill a hole in the front panel in this bracket here and mount our new balance pot on the front panel, sticking out here somewhere. There's enough room behind the front panel to accommodate it, I think. I hope. We will find out in a bit. On the shaft of the pot, I've 3D printed a little lever. It's like a little fork thing. See that there? And the idea is that's going to be on the shaft of my pot. And my original linkage from the lever that originally operated the slider, that's going to sit back on its peg here. The arm is going to fit in this slot, and when I operate the front panel control, is there a camera getting this anywhere? I'm sort of in the way of everything. When I operate the lever, it's going to turn the pot. That's the plan. So it'll sort of do this. Okay, now this is very much a prototype piece. Yeah, first things first is to try and work out where the middle of our slider was, because that's where I want to drill the hole for the pot. So yeah, we should be all right. Now, this has a very big drawback. Obviously, to get the complete movement from left to right on this pot, I need to swing about 270 degrees. And with this, I'm going to swing a lot less than 270 degrees. But whilst I won't get fully left and fully right, when do you ever need that? I don't know. Very rarely. At least we will have some movement between left and right channels, and I think that should be enough. If it's not, I may have to come up with plan C. Now plan C involves me removing, now this is the sort of concentric arm with the pip on it that our lever fits onto, that our front panel control bolts to. And plan C is to remake this as a 3D print without the lever on it, but with a toothed wheel on it, and then run a timing belt between that and the pot, because despite the fact the lever normally only moves sort of this much, it would actually swing all the way around. So I could get 270 degree of movement there. But first off, I'm going to try the lever option, because one, I haven't got a timing belt that's the right size. In fact, I don't think I have any. Oh, I might have. Anyway, yeah, I won't have a timing belt of the right size. And I don't have, I haven't bothered with any 3D printing of that. So first things first, I want to roughly measure up where my pot wants to be. I'm going to use a Sharpie. That can stay there for a moment. So that is about the centre line I want to work on. I'm only going to rough this out. I don't need to be super accurate with it. And that's pretty good actually, because that is smack bang. Yeah, I wonder if I just measure that actually from those two outer holes, because that don't look right. So where are my two outer holes? 39 and a half, so about 20 mil in from there. Yeah, it's a bit left of there. Let me just remove that mark before we go make a fool of ourselves. Yep. Even if I don't quite get it central, I can always tilt the pot. So that should work. Right, let's put a line down there. The trouble is, this bracket is right in my way. Most unpleasant. I think I'll use the fat end after all. Like I said, I want to get it semi-accurate, but I don't have to be super accurate. Anyway, somewhere on that great big fat line there, that'll do. And then I've got to eyeball the height of the pot, because it does hit. I want to get it as high as I can, really, because if I'm swinging at the top of this lever and I've only just got the lever in the top, our movement will be like that. If it's down here, we will be able to pull and push a lot further. I may have to re-engineer this in the final thing, because I'm a little bit worried about that moving up the slot and then sort of getting half stuck and just generally making a nose of itself. And the original pot did in fact have a complete hole in it, so that needs to be sort of as high up as possible, so that lever is as short as possible. And I think that's about as high as I can go, which me eyeballing it looks about there. So let's have a go at knocking a hole in our front panel at about that point. And yeah, we'll see if this is going to be a goer or not. Right, I'm going to need some form of centre punch. There is one in the drawer of tools somewhere. There it is. Fabulous. Oops. Right, one hole drilled. Let's clear a lot of this swarf out. We'll give it a proper clean up at the end. Let's just see if the pot fits in the hole. It does. Rather well. Jolly good. Right. So my next problem is my little lever assembly is going to be too long, but that's okay because shortening things can be done quite easily. I'll use this set of cutters. I shall just lop the end off it for now. Bit more than that. Right, we've got a start here. Nut and a washer on the pot. Get a little spanner on there, tighten that up. Yeah, okay. Right, let's centre that up. Get my linkage on. See if we're going to be anywhere near functioning. As I say, this is all a bit prototypey at the minute. I think that might be better on going that way around. Maybe not. As you were. If I need any fine adjustment at the balance centre, I can actually just swing the pot a little bit, which will be a little bit useful, I'd imagine. Right at the minute, I may have made the hole in the middle of my bracket a little bit too small. Come on. I wanted a good tight fit. I think I may have been a bit over keen. Yeah, I may have been very over keen. Well, no, not quite. I think I'm going to struggle here. We need to make that dimension in the centre just a little bit bigger. Yeah, let's do that. It'll only take a few minutes to 3D print such a little part. So do that and I'll see you in a moment. Right, I've 3D printed a smaller part. I've also shortened the legs on it, the ears if you like. So yeah, let's try and get that assembled. Pushes nicely on there. Goes nicely on there. Yeah, you see, I thought that might be a problem, that the lever does pull out of the end, but I want to sort of get a grip on where it sort of feels happiest, so I can make something with a hole in. Yeah, well, that's working. So if we can get that to be quite short, put a hole in it, that should do us. Yeah, goes all the way over that way. And it'll go all the way over that way. So yeah, I reckon we want a hole just 3/4 of the way up there. It's going to mean 3D print another part, but we are getting there. So I reckon our hole needs to be, Yeah, about 5.75 millimeters away from that. Right, 3D printing again. Right, third time's a charm. That's what I've now got. I've taken that rubber sleeve off because it hasn't got a there's a red rubber sleeve on the end of the lever because it hasn't got a grip into the top of a slider anymore. So right, let's see if we can get this on. I did put the multimeter on the pot and try and centre it up as best I can, but I may have to move it anyway to get it to mechanically behave. But I think we should be somewhere like that. It's getting stuck. Thought that might be the case. All right in that direction, but this direction, oh, I don't know. Trouble is I can go a lot further one way than I can the other. And we just slipped off. Okay, let's just try this going the other way round. It's walking its way up the shaft, so I'm just going to try that way round. Let's centre the pot again. I'll just show you how I did that. It's so easy. Multimeter to ohms, and basically you want to set it so the centre pin, which is the wiper to one side, is as near as damn it as you get to the other side. That's 986, 910. Edge it a little bit that way. What have we got now? 973, 930. To be honest, that's good enough. So let's just hook that end on there again. Try it this way around. I'm walking my way out the other way now. Alrighty, that's not a problem. I might just put a dab of glue or something on this lever just to hold it onto the pot. Let's slide that in from behind. Can I do it without... No, let's take it back off. It really isn't much of a bother. Right, let's try it that way round. Centre my pot again. 940. Wow, it's the best I've ever had it, I think. Centre that lever there. Get that on the end there. Get that sort of lever levelled up. Push that on. That works much better like that. Yeah, I can go further one way than I can the other, because obviously I can't pull this lever down any further past the fulcrum, because if we ever did that it would all come horribly to an end. But that way it does move over until it butts up against the shaft. Well, it's not a bad job. Shall we see how it performs? I'm just going to pop that in the centre there, see what our central position looks like on the pot, because I will be able to manipulate that. Oh, 764, that's going to be well over a K on that side. Yeah. What I need is a little screwdriver. Hold that level, and I think I can just move the pot a little inside there. It is only a quite a light friction fit. see what that's like. 882, still going to be too far. Yep, okay. A little bit more. $981, 908. That'll do me. I'm just going to put a dab of, I don't know, some adhesive on there. What have I got? Actually, just in case it all turns out to be horrible. And I end up having to do something else. Am I worried about it anyway? Probably not. Let's put a dab of high viscosity super glue on it. I think will be the answer. Just, you know, if I do have to snap it off, I have to snap it off. And yeah, we'll think of something else. That should just secure that on there. Right. So the next thing to do is to make it work electrically. I'm going to clean all this swarf out of here off camera. I'll get some IPA in there and just wash it away. I put some WD-40 on there to lubricate my drill bit, and it is it's stuck in the little bit of WD. So I'm going to clean all that out off camera. And then we've got to work out our pinouts on the pot. I think that's one end, that's the other, and the whole off centre there is the wiper. But I can confirm with bits of the pot I've got left, yeah, the off centre pin is indeed the wiper. So yeah, now I think they're cross wired, but as long as I get the wiper in the right place, I can always just manipulate the wiring just on the top of the pot here. That's all quite good really, because it doesn't interfere with that bracket after all. Just a little bit of a shame it doesn't go all the way to one side, maybe as I'd wanted, but I think it's a reasonable compromise. Let's see how it performs. On with the electrical bits. Right, let's see if it works. Right, I'm all reassembled, but I make one comment. I haven't put the volume knob on yet, because Quad have left us a sort of crescent shape, so you can actually adjust the zero position of the balance anyway. So centering that pot up, not such a big headache. Anyway, I'm going to switch the dear old MP3 player on and select some licensed free music. There we go. Switch on, and I'm on the... I was going to say I'm on the radio input, and we're in stereo.
Wires twist and currents run as broken notes begin to string
and the balance control is working. I mean, you can see this on camera, but it doesn't go far left, but it does go all the way right. But the centre line's pretty good. I'm pleased with that. That's not a bad modification. Right, let's just check the other inputs. Let's go into CD. And
Broken chords, a fractured song.
yeah, that's working. Tape. Yep. And finally, the disc input. I might wish to do something with that anyway. For the simple reason, I want to put a phono amplifier in here, I think. But no, it's working perfectly. What a marathon job. So what have we had? A reefer, the switch-proofed innocence, we had a solder blob, balance pot, and we've been all over this thing with a rash. Oh, there's a couple of caps that were shot away as well. That standby fault in the beginning, muting fault. Yeah, but now it's working great. So, I'm just going to make my mind up what I'm going to do with that phono stage. Right, well, I've removed the CD input card from the back of the preamp for the simple reason I don't see much point in having two CD inputs. Alright, this one's got phonos and the other's a DIN, but I really don't see the point. So what we're going to do is we're going to fit a phono stage where this was. But I'm going to leave that till next week. So thank you very much for watching. Click like, subscribe, do all that rubbish, and I'll see you soon, and we'll get a phono stage. Cheers now. Bye.
Stereo's gone dark, no more music in the park. Dolls at the shop in town, swear I'll turn this around. Speakers full of fuzz, my heart's breaking just because I miss those melodies. Need that fix to put me at ease. Dolls has got the tools, oh, he's fixing all the rules, oh, gonna bring my music back alive. It doesn't shop or thrive. Walking through that door, familiar faces I've seen before. Guitars hang on the wall, records stacked and standing tall. Handing in my gear, nervous but my fix is near. Can't wait for that sound when he turns it all back around. Does he's got the tools, oh, he's fixing all the rules, oh, gonna bring my music back alive. Does his shop all thrive? Was and circus man, a broken heart, my friend. Music heals the soul.